Okay, good morning all. I'm Dr. Chandrasekhar Pagasnalli, Assistant Professor, Department of Civil Engineering, BMSIT Institute of Technology and Management, Bangalore. So, we are going to discuss about the thickness problem. What is the thickness problems? Thickness of the strata. We need to determine the thickness of the different strata in the subsurface. So, here it becomes necessary to determine the thickness of the rock beds in cases of excavations, civil engineering projects, quarrying, support and lining of the sections, support and lining of section of tunnels, and even in canals for stabilizing the rocky areas, especially in the slopes. And the thickness of the bed is measured perpendicular to the bedding planes, and it is called a true thickness, and thickness measured vertically downwards between the bedding planes in case of inclined and folded beds and are called vertical thickness. Okay, these are the two types of thickness: true thickness and vertical thickness, right? So here, and so that the thickness is measured directly by the measurement of tape, commonly in the most of the cases. However, the direct measurement may not be possible, especially in the slope areas. Okay, and these are the two types of the thickness will be here. Okay, and there will be some equations are there to solve this, especially the thickness problem. Okay, and one is called true thickness. Okay, the following equations, there are three equations are there to generally identify this. One is mathematical methods. In that there are three formulas. One is true thickness is equal to Tt is equal to W sine theta, W width of the outcrop multiplied with the sine theta, and vertical thickness W tan theta. Okay, and the another one is called, in different case, true thickness is equal to vertical thickness multiplied with the cos theta. These are the three problems. Now, so here there is a called diagram, and here you can see this, and this is a surface of the earth. This is a ground surface, and this is this portion from O to O is the observation point, A is the another point. Okay, from here to here, the rock is exposed on the surface of the earth. This is a ground surface. Rock is exposed on this surface of the earth. This we call it as a width of the rock exposure. That we call it as a W. Okay, and O is the observation point. From this point, how much distance of the rock is exposed on the surface of the earth? That is up to the A. That's we call it as a W. Okay, and since this depth, especially this bedding planes are dipping towards eastern slope, eastern side, and this contact of the bedding planes. So there are two contacts. One is upper bedding plane, and another one called lower bedding planes. This is called LBP. This is called a UBP. UBP is nothing but upper bedding plane, and LBP is the lower bedding planes. And this is, we call it as a vertical thickness. Why we are calling it a vertical thickness? This is perpendicular to the strike line. It's a perpendicular to the ground surface. And another one called true thickness, actual thickness of this exposure, actual thickness of this rock bed exposure. It's called true thickness. This true thickness is perpendicular to the upper bedding plane. This is a strike line for this, and this is a DP. So this is a true thickness, and this is a vertical thickness. So these are all some of the the terminologies we need to follow. This O is the observation point, and GS is the ground surface, dip of the rock bed, angle of inclination of the bed. This is called a dip of the angle of inclination of the bed, and width of the outcrop, and true thickness, vertical thickness, upper bedding plane, lower bedding plane, and dip amount and dip direction. And this is a dip direction. We call it as a dip direction. These are all the some of the terminology for here. In thickness problem, there are four types: type 1, type 2, and type 3. There are three types of problems are there. One is that's called you need to determine in a type 1 you need to determine true thickness and vertical thickness, and we'll give the given data will be the W, width of the outcrop, dip amount and dip direction we are going to give, and remaining true thickness and vertical thickness you need to calculate. So this is a problem. This is how it the bed is possess a true dip amount and direction of south 55° west, okay, and the surface of the ground is called ground is leveled, and the distance between the upper and lower contact of the bed measured perpendicular to the strike direction. That's called 250 meters. So need to find out the true thickness and vertical thickness of the bedding planes. So now here you need to understand that. So in solving this problem, there are two methods. One is graphical method, another one is called mathematical method. By using the equations, we need to solve this problem. That's called a mathematical method, and by doing the graphs, drawing the graphs, that's called a graphical methods. Okay, now here we need to draw this ground surface first, okay, and then we have given the dip amount and dip direction, width of the outcrop. And first draw this ground surface, mark this A point, okay, and mark this A point first. Then we know the width of the outcrop first here, WOC. That's called the width of the outcrop. That's called a 250 centimeter. Again, you need to take the scale here. That is 1 centimeter is equal to maybe the 10 centimeter or maybe the 20 centimeter based on your requirement, or you can do it 1 centimeter is equal to 100 meters, so that you will get a 2.5 centimeter here. So first point you mark it here, and the width of the outcrop you have given, you check it. This is 250 meter. It's called a 2 centimeter. You can mark it, and we know the dip amount here. So dip amount is 55°. Which side? This is the west side and this is the eastern side. So we have given the dip direction, so called we need to draw this side. This is called the western side, this is the eastern side. So here dip amount is 55°. So here fix the protector and mark the 55°. This is called a 55° angle. And draw this upper bedding planes, okay, and parallel to this draw this another contact, that's called the lower bedding planes. So you got dip direction and dip amount also. So we got the width of the outcrop. So we need to calculate the vertical thickness and true thickness. Vertical thickness, you need to draw the line perpendicular to the ground surface and measure it with the scale. You will get the what you call vertical thickness 370 meter. It's nothing but a 3.7 meters here. So true thickness perpendicular to this, you need to draw this perpendicular to the upper bedding plane. You need to draw the true thickness line and measure with the scale. You will get a 210 meters. That's called a 2.1 centimeter. This is a graphical methods. So now let's start with the mathematical methods. So we have some equations to solve this problem. So true thickness, how to identify the true thickness? True thickness, we need to use this formula, Tt is equal to W sine theta. We have this W here, W value 250 meters. Multiply with the sine theta. Angle of inclination of the bedding plane is 55°. So we have here, so Tt is equal to 204.78 meters. Okay, so this is the true thickness, and vertical thickness is equal to W multiply with the tan thetas. 250 meter we have the width of the outcrop, multiply with the tan theta. Theta is the 55° angle. So you got this. So this true thickness and vertical thickness, these two values, final values, should match with this graphical methods. Okay, and it's a very difficult to match this because maybe a graphical error or maybe a human error, it may not match these two, but it should not be a long, it should not be the more gap, like a more than 5 centimeter or more than big figure should not be a difference here. Okay, there should be a matching these two. So that is a one type, and this is the same problem here, and this is called type 4 here, type 3. Okay, this is a type 2. Okay, this is a type 2 here, and the given data will be width of the vertical thickness, width of the outcrop, and dip direction we are giving. All we need to do, we have to determine the true thickness and dip amount. So vertical exploratory borehole drilling for coal seam touches the upper surface at 60 meter and lower bedding plane at 200 meters. Okay, so its width of the outcrop is 600 meter on a level ground, and it's a dipping eastern direction, and we need to determine true dip and amount of dip. So all we need to do now, so given this 600 meter width of the outcrop, so you need to draw the ground surface first. Okay, you need to draw the ground surface first, and then you need to mark this A point here and measure the 6 centimeter, say 1 centimeter per 100 meters, 6 centimeter, mark the another point. We are given the what you call the dip direction here. This is the eastern side, it's called eastern side. Okay, and also we are not given the dip amount. We have to identify here, determine here. Okay, so now here we need to draw this ground surface, mark the point A, and another contact is B, and these two are contact of exposures of bedding planes, and the distance is 600 meter, and we have the dip direction of the bedding planes. That's the eastern side. We don't have the actually what called dip amount. So all we need to do now, we have the upper bedding plane contact and lower bedding plane of the contact. So lower bedding plane of the contact is 200 meters. Upper bedding plane contact is 60 meters. So 200 minus 60, you will get the vertical thickness of the bedding planes. So here we can get it, Vt is equal to W tan theta, and Vt is the 140, that's 200 minus 60. You will get 140, that's equal to 600 by 600 multiplied with the tan thetas. Okay, so here we need to calculate theta values. Here theta is 13 degrees. You got the 13 degrees, and you mark this one first, angle of inclination of the bedding planes. Now you need to mark this the vertical thickness, so 140, you got it here, perpendicular to the bedding on the ground surface. You mark this and measure this, how much it is coming, and perpendicular to the upper bedding plane, you draw the line of true thickness, measure it, how much it is coming. So this is a Tt is equal to Vt multiplied with the cos theta, and so 140 is the Vt, we got it here, and cos 13.13, this is angle of inclination of the bedding planes, and all about 136.29 true thickness will get it, and vertical thickness is we are already given, that's called the WC. This is all about the thickness problem introduction part, as well as the type 1 and type 2 method. Thank you very much for participating in this session. Thank you one and all.